Okay, class, we're going to start getting into chemistry, talking about elements and the periodic table. So first we have to know what chemistry is. Chemistry is the study of the properties of matter and how that matter changes. So everything in the universe, everything, is made up of matter. And then that makes up everything that's around us, whether it's things we use in daily life, whether it's made of one element or multiple elements. So things that we made out of elements would include just an endless list. Your cell phone, your clothes, water, money, clouds, the sun, just everything is made of matter, which is made up of either one or multiple elements. An element is a pure substance that cannot be changed into simpler substances. So if you have a piece of gold, then that is one element, and it can't be broken down into anything simpler. And then each of those elements are made up of super small particles called atoms. So usually we don't get to see elements. A lot of things that we think of in our daily lives are going to be made up of more than one element, but some of them are made up of just one. So let's look at a few of those examples. Aluminum foil. So aluminum is an element on the periodic table. That would be an example of just one element. Carbon in your pencil. So we call it lead because it used to be made up of lead, which is an element on the periodic table. But with scientific advances, we figured out it was kind of dangerous for people. So it's actually graphite, which is a form of carbon. That's one element. Gold or silver in jewelry. That's a specific element. Nickel in nickels and the copper coating on pennies are one element. Tungsten makes up the wire that glows in light bulbs, which is an element on the periodic table. So these elements on the periodic table are going to be represented by letters, so either one or two letters, and they're going to be organized in what we call the periodic table of elements. So you're going to think of these as kind of like an alphabet of elements, okay? Each of them is going to have a letter that represents that element, so we don't have to write the whole long word out every time. For example, lithium is represented by a Li. Notice that the first letter is always capitalized. And vanadium only has one letter, so it's just a capital V. So those are the element symbols. That's what represents that element when we represent them in chemical reactions. There are 6 that you need to memorize. The elements you need to know the symbols for are sodium, which is Na, chlorine is Cl, hydrogen is capital H, oxygen capital O, carbon is capital C, and nitrogen is capital N. So those 6 need to be memorized. Your periodic table also has some other symbols or information. For example, if you see a solid cube in the square, that means that that element is solid at room temperature. If there's a little raindrop, that means it's going to be a liquid at room temperature. And if there's a cloud, that means it's a gas at room temperature. Now this is just an example. The one that you have has these symbols. Not every periodic table has the same amount of information. So if you look here, you can see most of the metals are going to be solid at room temperature. If you look to the right-hand side, a lot of these nonmetals are going to be gases. And then there are 2 elements that are liquid at room temperature. So just some extra information that is available to you. Another symbol on your periodic table is that some of them have a person in them. If there's a little man in the square, that means that it is man-made. If there's no man in the square, that means it's a natural element. So you can see from this example, there's some usually towards the bottom here. Some of these have a person in them. That means they're man-made elements. Another symbol that's important for us to know is this one. If it has this symbol, that means that it is a radioactive element, which means it's dangerous to humans. If there's no symbol, that means that it's safe. So again, a lot of these you can find towards the bottom here. Radium, uranium, these are the radioactive elements. The periodic table is organized, so we're going to look at kind of how it's organized. If we think about organizing things in our life, for example, in your kitchen, you would put things that need to stay cold in the fridge. You would put cans usually in the pantry. Pots and pans would go together. The periodic table is organized in a particular fashion based on the properties of those elements. Okay, so the first thing we need to know is that elements in the same column, this means up and down or vertical, they're called a group or a family. If you look at your periodic table, there are 18 of them across. So if we go back here, if you count across this direction, there are 18 of them. Okay, so that's a group or a family. If you go the other direction, elements in the same row from left to right are in the same period. So I think of it this way. If you're going from left to right, you're writing the sentence, and then there's your period at the end. They're horizontal rows. So if we look back at our periodic table, okay, so if we read across Hydrogen and helium are in the same period. Period 2 would be right here, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. Okay, so periods are horizontal rows. Two other pieces of information each periodic table square is the atomic number. This is the number of protons and electrons that element has. We'll talk more about this later, but for now just know that it's the number at the top of the box. These numbers do not repeat, so that's how the elements are organized. Notice that hydrogen is 1, helium is 2, lithium is 3, etc. So if you go from left to right, top to bottom, each of those elements will be in order. So the atomic number is at the top. The atomic mass or weight is the number that's at the bottom of the box. This is the number of protons plus neutrons that an element has. So again, we'll talk more about those later. Just know that that's the number at the bottom. And those also increase as you go up in atomic numbers for each element. There's also a zigzag line that's towards the right side of the table. It kind of looks like a staircase. And this is what's going to separate the three groups of elements known as metals, nonmetals, and then metalloids, which we'll talk about. So generally speaking, if we go back here, the zigzag line is going to be across this direction. The metals are going to be on the left-hand side, and the nonmetals are going to be to the right of that line. So if we look here, in our key, everything that's yellow is a non-metal, so including hydrogen over here, and then everything towards the right of the staircase. Those are all non-metals. Everything in blue, so all this section, and then these two rows down here are metals. And then along this zigzag line are what we call metalloids, and these are elements that have properties of both metals and non-metals. And then each of those groups have characteristics or properties that separate the difference between them. Okay, so metals have 5 characteristics or properties. The first one is luster. That means that they have kind of a shiny surface. They reflect light brightly. So if you think of ever looking for your reflection in the back of a spoon that's made out of metal, it's going to have a shiny surface. Metals are also conductors, so that means that heat and electricity can go through them. If you touch metal that's been in the sun, if you go to the beach on a summer day and you get back in the car, you touch the metal part of the seatbelt, it's going to be really hot because it's been collecting that heat all throughout the day. Metals are also malleable, which means that they can be hammered into shape. So this is where we have aluminum foil and statues and musical instruments. They're going to be made out of metals because they're really easy to bend into shapes. Or if you've ever bent your spoon or your fork and you were able to kind of switch it back, metals are malleable. They're also ductile, which means that they can be pulled into a wire, which is really convenient because we've already talked about how they are also conductors. So we use them for a lot of electronics. The fifth is that they have a high density. This means they're really heavy for their size. So if you picture this element right here pictured as osmium, it's the most dense metal on the periodic table. So 1 cubic foot of osmium is 1,400 pounds. Okay, so that's obviously an extreme example, but they have a really, really high density. Okay, on the other hand, nonmetals have 3 properties that are pretty much the opposite of the properties of metals. They're dull or not shiny, they're non-conductors, so heat and electricity do not move through them easily, and they're brittle, so they're not easily bent. If you try and bend them, they're probably going to break or shatter really easily. Okay? Properties of metalloids, they have properties of both metals and nonmetals. For example, they may have luster like a metal, but they're brittle like a nonmetal. So to recap, the periodic table is full of information about each element. We talked about elements that are a solid, liquid, or gas at room temperature, elements that have a man in them or don't, whether they are man-made or natural, if they have a radioactive symbol or not. It's also organized based on the properties of each element. So you've got your metals, nonmetals, and metalloids. The atomic number and the atomic mass also organize each element and where they belong. You've got your families and your periods. So remember, families are vertical rows or up and down, and the periods are the horizontal ones. And then we covered the 5 properties of metals and the 3 properties of nonmetals. And that's what you need to know about elements in the periodic table.